I want to go back to the smart system. Yeah, so the first one, when I calculate, it doesn't save automatic. I don't know.
Is that when you calculate, it doesn't show automatically.
It doesn't save
It
because
doesn't
all
save.
these things, all the models, yes, all the models, I've calculated them, but I have to recalculate again before it can show. I don't know whether you're seeing my screen now.
Oh, okay. So right now you have not done anything
Are you
new.
seeing my
That's why
screen?
it's yes, I can see your screen. You have not done
Yes.
anything new. That is why the save is inactive.
Is that?
So try and then you try and move the arrows for digital access to the left. So select that, then move it to the left.
Yes, I did
Go
that,
to-
and yes, I did. It's not like this.
exactly. So you can see that the save has now been activated.
Yes,
So
but when I
okay,
save and I go back, it will still give me, okay, let me save and go back. You see
to
what
save and
what
go
it
back.
give
Let's
me.
see.
Yes. Okay. Okay. So it's saved. Let me go back. So I'm opening it again.
Okay.
You see that the this thing is off, it's not there.
Oh yeah, whenever you open the software, this is how it's supposed to be. I mean, there shouldn't be the values for you to see. So you have to
Oh, okay,
recalculate.
okay.
It should not give you the
Oh,
value.
okay, okay.
Whenever you
Yeah, I saw some.
run, very good.
Okay,
When you run, you are supposed to save your output. So maybe by the time you are done, we see how we can save this output for future use.
okay,
But once you come back to
okay,
the software, you have the model, but the calculations and everything, you just have to rerun them again. Uh,
okay. So let me show you the other models that I'm able
so
to do too.
show to us the other model. Let's see.
Okay.
Mhm.
So this is from live support, live,
Learning support.
yes, live
Learning
support
support and
for
academic
academic.
outcome. Good. So you can move that to a bit right. The learning support, move it to the right side. The construct itself, move it to the right. So select and then move it to the right so that you have enough space to no to the right, to the right. Mhm. Good. Go further. So now you can move the so that is how it is.
So I should calculate it for it.
So now
So
you have
should
to
I calculate correctly?
rerun it and let's see
Yes.
what you got. So start calculation. So that is it. Good. So I think you are good.
Let me show
Do
another.
you have any
Let
question
me show another model.
based on what you have done
Let
so
me show
far?
another model. No, I've done another
Hello,
creating model. Yeah.
can you hear me?
Yes, I can hear you.
Yes.
I
So I
can
think
hear you.
that is all. So you have done well. I mean,
I've
you
done
practiced.
I've done another I've done
Okay,
another
so you can show
mediating
us
model.
quickly so that
Okay.
another person will
Okay.
also be able to demonstrate to us what he was able to do.
Okay.
So you see, uh, where the indicators are pointing into my
Yes.
PLS, you're supposed to make sure that if it is dependent variable, basically point it to the left side, okay,
Okay.
or
Okay.
to the top, depending on how many models you have. All of these
Okay.
depends on you, but that is the standard thing normally we do, so that other people would know what variable you are really dealing with. Good.
Okay.
So now it means that you have made behavioral engagement a mediator, right? Because it is in
Yes.
between platform quality and then
In yeah, in
uh,
one of the models. Yeah.
thank you very much. So this is another model that you have created. So far, so good.
Yeah.
So I think if there's no question on that, you can drop, and then somebody else who also tried will also share to us.
Okay.
And if
Okay.
there is
Okay.
any questions to
Thank you.
us, thank you very much, Mr. Mawuli.
Okay. Thank you.
Okay, so is there any other person who has done the assignment? Let's see. Can you let us know? Then you share your screen.
Hello. Hello, sir.
Yes, sir. I
Yeah,
do, Mr.
yeah,
Adu.
I also tried my hands on
Okay,
phone.
so kindly share your
So,
screen. Let's see what you've been able to do so far.
all right, sir. Please, can you see my screen?
Yes, we can see your screen now.
Okay.
Don't worry, it will respond.
Okay.
So, is there anybody using Mac who has not been able to get the software installed? Or so far, everybody is using the Windows. Okay, so now we can see your screen. Okay, so this is the first one, right? This is
Yes,
what we did
please.
yesterday. So did you do anything else? Or you want to try this? You can run this and let's
Y-
see your model. Okay, that is right. So the same thing that we got yesterday. So we are on the same you're on the same line.
So I
Okay,
go
thank you very
to
much, Mr. Adu. Is there any other person who want to also demonstrate to us what the person did? Um, you have Gifty BB. Gifty BB, yesterday you had issues with the model. I don't know. Did you try your hands on it? Are you good? Salifu Adam. We have Martin, Alexander, uh, Romana, Sharon, Adams, and a lot more. Okay, so that means we are all good. So let's proceed with today's class. So yesterday we demonstrated how to create some models, and that is what that is where we ended. Uh, please, can you see my screen now? I hope you can see the smart PLS screen.
It's not loading. Not
Oh,
on it.
okay.
Okay. Yes. Yes. Come.
Yes. So this is where we got to yesterday. Uh, so this is mine. So as soon as I open, if you want to see the values, you just have to rerun the model again, and then you're good. So this is mine. So today we are going to add more models to that, right? So if you can recall, yesterday that we had different constructs we could deal with. So today we can add more to that. So let's say we have platform quality. We want to add platform quality to it. What do we do? We have to select, right? So So platform quality. You can see that whenever I do that, it automatically runs for me because I've activated recalculate automatically. Okay. So if you don't want that, you can just deactivate it here, down here. So once you do that, automatically it will run it for you. So let's add one more to that. So we can add maybe the L is learning support, right? So that L is learning support. So this is it. Then I can just select automatic calculation. So you can see that it has run it now for me. So we have three models that is predicting academic outcomes. All right. Yes. So this is where we ended at the last time. Now let's look at, we all understand that the circular diagrams that we see here are all the indications of our latent variable. And then the yellow ones that we see here are the indicators, right? And yesterday we discussed that there are two fundamental splits that are paramount in smart PLS, okay, or PLS SEM. The very first one is measurement. So first, we discussed that we can look at the indicator loadings. And we said that the loadings has to be greater than 0.7, right?
Oh, Charlie.
So
I do.
the software gives us this result from the very first time we interpret it, okay? So anything that we see here, you can see that the PQ1 or to PQ4 has a specific loading, okay, attached to that. And we said that the threshold is supposed to be 0.07, greater than 0.7 or 70%. So we can see that we have here 0.8 all the way to 0.888. So everything here has met the condition. So this is the very first measurement assessment we are supposed to take into consideration, the outer loadings. Okay. So we have met this condition. We also said that you are supposed to check for validity, right? And we can see that also from the very first interface that we see here. When you hover your mouse to the construct, you can see that the result also comes in here. So we have the composite reliability, we have the average variance extracted, Combax alpha, we have the composite reliability rho C. Okay, so even without going to see the full report of our model, you can have access to them here. Okay, and then we work on it before we proceed to even export our results. So you can see that here, our R square. So the R square is what is in here, 0.482. And it means that these three predictors explains about 48.2% of the outcomes in academic in the outcomes in the latent variable here called academic outcomes. Okay, so let's see, adjusted R square is 0.479. And then our composite reliability, which also measures reliability. As we mentioned yesterday, we saw that we have three main methods that measures reliability. We said the Kumak alpha. So here the Kumak alpha is 0.867. So you have met, it is more than the 0.7 threshold. And then the composite reliability, which is the rho A, is also 0.7. Same applies to the composite variability we will see 0.909. So we have met this criteria. So you can hover on this as well, and then you realize that this has also met all the criteria above 0.7, above 0.7 for all the reliabilities, and then above 0.7 for all the reliabilities. Same applies to the validity, and we demonstrated that we have two types of validity, or two methods for assessing validity. And we mentioned that we have the convergent validity, which we use the average variance extracted to assess that. And the threshold is always supposed to be above 0.5. So you can see from here, average variance extracted for the latent variable data access is 0.7, so which is above the threshold 0.5. So we are good. Let's check for this one. It is 0.711, so we are good because it is above 0.5. This too has also met the criteria. So the very first interface has been able to help us to at least get much information about how our measurement model behaves. Okay. You can also check that in open reports. Okay, Mr. Mawli, you can ask your question.
Yeah, when we use all the six variables for the platform quality, the average variance extracted is less than 0.7. But when you use 4, it's above 7.
Please, can you come again? When you use all the six, okay.
Yes,
So,
please.
okay, that means I even left some out. So let me bring them in here. And then this one as well. So is that when you use all the six? So
Yes.
this is mine, 0.680.
Yes.
Uh-huh. So
Yeah,
still
say it's less than 0.
it is more than 0.5. The criteria is
Okay.
0.5. Uh-huh. So you can see that it's more than that. Is there anything that we have left? Let's see. Data access is 5, right? Then this is also 6. Learning outcomes is up to 5. So that means we have been able to make use of everything. So if you want to find out,
Okay.
when you select, you realize that it selects what is in there for you, right? So once you start to select that, you see that it is highlighting them for you. But it will even help you to notice whether you have missed certain things out. So far everything is intact, right? Mhm. Yes. So
Yes.
now we can also open the full report. Okay. You can do that automatically. For example, when you are running the model, you see somebody did that yesterday. You can just check this one. Once you check this, when you run, you're not going to see this interface again. You're going to see different interface. And this is the same as not checking that and then you coming here to open the report. Okay, so now you see this is the new interface that we have. So this is the report interface. So if you don't want to access it from here, you can just automatically check the open report, and this will automatically open that interface for you. Okay, so now this gives us a broader view of the results. So now let's check. So this is the graphical interface. So it means that if you don't check for the full report, you only have access to the graphical output. And the graphical output is even enough to give you some basic knowledge about your measurements. All right. So now let's look at the final results. So now you can check for the path. Okay. So this is our beta estimate. This is also shown in the path here. So movement from here to here, the beta estimate is positive 0.5. Okay, 0.3, 0.30. So you can also see them here. And it has many different ways it can show you. So this is in the form of matrix. We have here to be list, and here is also in the form of graphs. Okay. So far, I've not seen any study that has been published where they presented their results in the form of graphs. Yes, because if you have to do this graph, you're going to have so many graphs in your paper. So normally presenting them in a table form is always the best. You can also have the total effect. same values as the path. We have the outer loading. So here we can assess the outer loadings. That is one of the very first measurement criteria to assess, and it's supposed to be more than 0.7. So you can see them here. And one thing that makes the smart PLS software handy to use, even if you are a new user, is that it makes use of different colors. So whenever you see green colors, it means that yes, the criteria has already been met. So even if you don't know, if you don't have any idea about the criteria to assess or to use as a benchmark for your assessment, it means that the colors are enough to demonstrate to you that yes, you are good. So green means that yes, the criteria for this one has been met. Okay. And if you see red, it means that there is an issue. It could be that the criteria has not been met. And sometimes you can see the values in black. So it means that it is not it is acceptable. It is not above the criteria though, but it is acceptable, right? So these three colors are very important: the green, black, and then the red. Okay, so we can go, you can check the outer weights. So this is also the weights assigned to the model. But so far, what we are doing right now, we term it as reflective. I'll come that in details. I'll come to that in details. But for now, we're not going to make use of the outer weights. But these are the weights assigned to each of the indicators. And if you can recall, yesterday we made mention of when to use and when not to use the PLSM. We mention in the last statement on the slide, we made mention that the PLSM is able to help us to create scores that will help us in to get the scores for further analysis, for example, cluster analysis, necessary condition analysis, and I even made mention of fuzzy set qualitative comparative analysis. That's FSQC, right? So this is where you can get the latent variable score. So once you run the PLSM algorithm, it gives you this as per the latent variable score, and then so this is the raw score. You can copy that to Excel. So just copy to Excel Word, and it is copied to your clipboard. You can just go and paste it there and then use it for further analysis. It also shows you the correlation among the various latent variables. So you can see them here, and then the covariance also here. The covariance also shown in here, and then I think it's now loading. Okay, so and then the descriptive statistics. So if you want to report on these, you are good to go. And then the residuals. The residuals are also shown in here for each of the indicators, and then the various constructs. Okay, so all of these things are not reported though, but for the purpose of you getting to know about them. And then this is our R square, also shown in here. So this is in the form of bar chart, and then this is a bar chart for just R square. And you also have F square, the effect size. Okay, so we are going to go into that into details. So now this is where we find our quality criteria assessment. So the very first thing you're supposed to even check out for is your reliability and what validity. Although we're able to get that in the graphical output, but we can find that in details in the PLS algorithm. So now we have them in table and realize that everything is shown in green. So it means that we don't have any issue here, right? So our chromac alpha is also all green. Composite reliability also green. Reliability, that is the row C, also green. Okay, so all of these things measure composite reliability. So in reporting, you can just report on all of these three. That is good to show that yes, your outcome is robust. So you can present all of these, or you can present on the chromac alpha and then the row C, because the value for the row A lies in between the alpha and then the row C. Okay, so you can see that this is 0.867, and then this is 0.87. And then the composite reliability rule C gives us a higher value. Okay. Okay. So they all have different weights that they assign to this calculation. So normally you can just report on the alpha and then the rule C, and you are good. You can also report on all the three. You are also good to go. So now you can see
Please,
that,
may I know the difference?
yes, I said that the reliability, the rule A, is more conservative. Okay. And it normally lies in between the alpha and then the rule C. So let's check this one. You have the platform quality 0.9 for alpha. The rule A is 0.910, and then the C is 0.927. Okay. So normally the rule C gives us better um, assessment for our model. For example, if you are using Smart PLS. But if you are dealing with SPSS, you can only report on the Chromback alpha. But for the purpose of you see, when you are dealing with SPSS uses your composite mean. Okay. It uses the composite mean. So with SPSS, you calculate the mean score for academic outcomes, even though we are using the Likert scheme. But PLSM uses latent variable score. And let's check from here. Um, so let's see our score. You can see that we have here to be 0.707. And here is negative. So this is how the latent variable scores are calculated. But if they were supposed to be the composite mean, okay, composite mean will never give us negative values in here because the scale itself is even from 1 to 5. And if I define the mean for values between or from 1 to 5, under no circumstance should we have negative value in it, right? So that's why with PLS SEM we also make use of what they call composite reliability because that gives us a better assessment of our reliability score. I don't know if your question is answered. So in
Yeah,
PLS,
okay,
what
I
we
get it.
normally check is composite reliability, but it's also good to report the alpha as well because you don't know who the reviewer might be. Okay, and it has also been a norm. So everybody is reporting on alpha, and then maybe composite reliability, and then you just ignore maybe the we'll see. They're going to ask you to report on that. Okay, for transparency purposes. So this is measurements of reliability.
So please, so in analogous term of maybe R square and adjusted R square. So in from that perspective, the Kruger alpha is more of R square, and the composite reliability uh, rho C is talking about the adjusted.
Oh,
Is that
okay.
a concept?
This I think there's a name for that, but normally it is shown here as we'll see. There's somebody who propounded this one, and there's another person who also has its name on there. We'll see. Okay, but so far, what I know is that there are different weights that are assigned, and based on my search, I know that the composite reliability gives better assessment. So it means that the alpha has its limitation, and I even used the fact that with PLSM it uses latent score. Okay, it uses latent score, but with the alpha, it normally we use with SPSS it calculates using the mean score. So the mean score are always positive values, right? But latent score can be positive and then can be negative. That is why with PLSM we normally base on the composite reliability for better assessment because of the fact that probably we use the latent score. I don't know if you're good.
Okay, I'm good. Thank you.
So that is the three methods for assessing reliability. Okay. So you can always copy that to Excel and then you paste it. You can copy it to Excel Word and then you paste it in your Word or Excel for purpose of export. You can also export it everything here in Excel. Okay, we are going to do that by the end of maybe the session or some other time. But for now, we just want to see how the values are being reported in the software. So now we are done with the reliability. Let's check for um, the discriminant, sorry, the convergent validity. So we said that there are two forms of, or two methods for the assessment of validity. And we have the convergent validity, which we use the average variance extracted. The average variance extracted. So, and the threshold is that it's supposed to be more than 0.5. So everything here in green. So normally it is shown in here under the section constraint reliability and validity. That's where you can find your convergent validity. But if you want to find the values for discriminant validity, you come to this section. It has its own values in here. So now you can see from here that these are the values for our discriminant validity. And based on what we learned yesterday, we discussed that the discriminant validity also has 3 methods for assessments. Okay. And we said that we have the ATMT, if you can recall, ATMT, and given to us here in the software in the form of matrix, list, and then bar chart. And we said that our ATMT is supposed to be less than 0.85. Okay. And it can go as far as 0.9 once you can justify. Okay, you can justify and say that probably sometimes when you are dealing with higher order constructs, there can be a very high correlation between the construct, the higher order level construct, and then the lower order construct. So sometimes there is high collinearity among the variables or the latent variables. So you can justify even if you have above 0.85, it is justifiable once you're able to explain yourself. And the review also accepts that. So now everything is green in here. It means that our criteria assessment for discriminant validity using HTMT, heterotrait monotrate ratio, has been met. So we are good to go. So this is also in the form of lists, and this is in the form of in the form of diagrams. Okay. So now we also discussed that we can use what you call Funnel-Lecker criteria. Okay, so this is the Funnel-Lecker criteria. And normally, this is a traditional way for assessment. Previously, this is how we used to assess discriminant validity. And with this one, it is the square root of the average variance extracted. So let's see. Let me share my screen in full. Okay, so now let's see. Okay, so we have this. This is the output. I've copied it and then I've pasted it in the Excel. All right. So now this values in here, these are our scores for Funnel-Lecker criteria. And here the criteria is that the score for each of the latent variable score is supposed to have a higher score than the corresponding latent variable score. So you can see that from here, academic outcomes has Funnel-Lecker criteria assessment score as 0.845. And compared to other latent score, we have here to be 0.523, 0.311, we can see that this one is bigger than all the various constructs that it compares with or it associates with. Same applies to the data access. The value for the data access is 0.893, and to compare to other score or other latent variables, you can see that we have here to be 0.03, which is less than 0.85. You have here also to be 0.032. Okay, same applies to this one. We have here to be 0.8, and this is negative 0. So this is far below. So that is how it is. Okay, so this score is calculated from the square root of the average variance extracted. So what do we get for the average variance extracted for academic outcome? So we have here to be 0.714. So the square root of 0.714 is 0.844. So same applies to the other ones. If you have to check for that one. So the software automatically does that for you. So that is the assessment for analytical criteria. I don't know if there's any question. If there's no question, we can move on to the third one, which is the cross-loading. Now, same applies to the cross-loading. Let me share that on Excel so that you can see it well.
Sorry, I posted a question.
Okay, please, you can go ahead.
So what if the other variable, the one that you mentioned that's supposed to be small, happens to be bigger than the score?
It means that there is an issue with validity. There is an issue with your data or the question that you have asked the respondent. Okay, right. So it raises issues about validity concern. These are all measurement methods. So it means that you have to check how you measured your variables and how the data were collected and all of that. Okay. So I will share data where you see some of these issues, and then we see how we can resolve that. But basically, if you pass through the right procedure by making sure that you set the right question, because the question that you ask them is what will influence the outcome that you run and get. Okay, so it means that probably your questions were not really answering the or the question that you asked the respondent were not really reflecting the underlying construct. So it means that the questions were not valid. That is why this can be an issue. I don't know if you understand my point. So the software is there to help you to understand whether yes, were your questions valid or not. Okay. Okay, so the third one is cross-loading. We also have what we call cross-loading. I also use cross-loading to assess your validity or discriminant validity. Okay, so let me see if I can highlight. Okay, so with cross-loading, okay, you can see that for academic outcome, which is the theoretical latent construct, and these are the various loadings, the indicator loadings. So it means that for academic outcomes, if it is to be loaded, if these indicators here are to be loaded onto another construct, the loading is going to be 0.4 for the first one, 0.4 here. And the criteria is that always the loadings onto its parent theoretical latent construct is supposed to be higher than other latent variables. So AO1 loads better onto if it is loaded onto data access. The same way AO1 loads better compared to if it is being loaded onto learning support. Okay, it loads better compared to if it is being loaded onto platform quality. I don't know if you understand it. Is there any question on this? So you can see from here too, digital access loads better on its parent theoretical concept than if you have to compare the values with academic outcomes and then that of learning support and then platform quality. The same way learning support, its respective latent score loads better onto its parent theoretical latent variable as compared to other latent variables. So as you can see here, so that is it. Any question on this? So you can report on that, and then I think you are good to go. Let me see. I think there was a study that we published. You reported on that. So let me show you that to you. Okay, so this was a paper that I published with my co-authors last year, and we use smart PLS. So this is yes, the model that we constructed, and let me see. I think we reported on. Oh, really? I think let me check the other papers and see. So you can check these papers out if you're interested in publishing using this method. So far, the forms that I posted on the platform, it's only 5 people that have filled the forms. And about only 3 people are interested in publishing with this method.
No, I didn't fill the form. I would definitely look for it and fill it.
I think I posted it on the WeChat platform. I
Okay,
think there was
I'll
a
check
paper
it
that we
out.
published. Okay, so you can check these papers out. Okay, so we use Smart PLS. Okay, so this is it. Access to finance. You can check it. This is an open source, so it is free. You can have access to that and read more about it. So you can see that we reported on all of these that we're talking about. So measurement model, we talked about reliability and validity. And then we also talked about discriminant validity. Okay, so that is it. So we can see that this is the row A. So here we reported on both alpha. So this is the alpha, Chromback alpha. And this is the row C, row A. And this is the row C. And this is the discriminant. This is the convergent validity above 0.5. And then this is the HTMT ratio. Okay, so you can see that here we already reported on the HTMT. We didn't do for the Fonalaka, right? So that is it. But you can as well report on the 2 and then you are good to go. And this is variance inflated factor to assess multicollinearity. Okay, so I think I'm going to demonstrate that as well. And this is the main model. So, and these are the scores, the indicator loadings in here. And then this is the outer loadings. So you can see that from here. So if there's no, okay, Martin, you can go ahead with your question.
Okay. While you were showing your paper, I saw that you reported both row A and row C.
Okay.
So in the case where you report, is it possible to report only row C?
Oh yeah, that's very possible.
Especially
It is very possible.
A is not really
Because at the
given.
end of the day, the values, you know that row C is going to have a higher value than what? The row A. So if you have this
Yeah.
and you have that, you know that this is in between. So even if you report on this and that, okay, definitely this is known because it lies in between. I don't know if you understand. It mostly lies
Yeah.
in between the values, yes.
Okay. So you can report on the Chromebook Alpha and then
And
row
then the
C
row
and
C,
then
yes. In
ABE,
fact,
right?
many studies that I've seen, they report on only, they even don't show that this is row C. They only say that composite reliability. And then that's
Reliability.
all.
Okay.
But when they say that, it means that they have reported on the row C.
Okay, great.
Yes.
Okay, thank you.
Yeah. So I think we can, if you have any question, we can pause now for about 5 to 10 minutes and then we come back and continue. Okay. So that we can see, because of the issue with long. Okay, could you, Bonzo, you can go ahead with your question.
Hello.
Yes, sir. I'm listening to you.
Okay. So, first of all, I want to ask you, say you posted some link on the page. What did it say? So, if it can be reshared on the page again. And
Okay,
Just
I'll do
update
that.
the form. Mm.
my questions are, so with the PLSM, the one that we've reported now.
Hmm?
So, you've run now the PLSM that you've run. So, what I want to find out is that, so what are the other constructs that we need to report them when you are writing a paper, because there are many of them there, and looking at even the paper that you've projected now, not everything that is here. So what are the other ones that one needs to report them when writing a paper using this?
Are you talking about the graphic or the tables to report?
Yes, the PLS, you've done the PLSM. So,
Okay,
we
okay.
have the construct there. We have many of them. So I want to know which of them that are there to report them when you are writing a paper or a thesis and you
Oh
use
yeah, you are supposed to report on the
Smart
measurements.
PLS.
You can see that we have, this is the demographic aspect of it, but what is very ideal, you're supposed to first look into your measurement aspect. So with the measurement, you can see that here we started with the measurement, right? So here's the measurement,
Okay.
and with the measurement, we discussed the reliability and validity. You cannot take this out. This is very core to your assessment. So you're supposed to report on reliability and validity. And the reliability alpha and the composite reliability, the discriminant validity, you report on, sorry, the validity, you report on the convergent and then the discriminant what? Validity, right? Okay, somebody asked the question. I said, can you ask for anybody who is using Smart PLS? Okay, so is anybody using MacBook here, or we are all Windows users? So Adu was asking that we should preview the title of the papers for me to take note of. But I don't understand your question. I should preview, as in, should I give you the titles or?
Yeah, I think he means the paper so that we can use it for reference.
Okay. This is even free, so I can. So this is the title of the paper. You can get it from Scientific Africa. Okay. Or you can just go to Google Scholar and then you search for my name. This is my full name, Frank Adimai. And these are the
Okay.
papers. So this is the first one I'm showing you. The access to finance, and then this is the digital transformation, also free. And the other papers, but this, I think this is also on Smart PLS. Let me check. I think all the Smart PLS papers are free. You can get access to them even if you are not in China. okay, this is also another paper. This was published in January this year, 2026. We use Smart PLS as well. And this is another paper. Also having, I think we use Smart PLS as well. And this is also free. You can get access to this one. This is business strategy and then the environment. We use Smart PLS as well. So you see, with Smart PLS, you can get a lot of papers to publish in. Okay. And you can also get top journals as well. So this journal, for instance, is a very top journal. Its impact factor of about 13 point something. So as a PhD student, if you are to publish for your supervisor, they are really concerned about the fact that the journal is high quality journal, and then it has a very good impact factor. So you see this one we use Smart PLS. So you can see it here. All right. So I think we can go for the break now. If there's no questions, then we can, but we can still be engaged.
Prof,
So
will it be
I'll
possible to help us with some few? Hello, Prof.
Thank you.
So let me go to software, and I wanted to show you. So let me come back to edits, and let me rerun again. Okay, so if you want to demonstrate that, you realize that you can see if you're using the latest model, the latest software, the 4.1.1 and above, you have this here. So you can see that in the diagram, we have the structural model. So within the structural model, what we see here, it is only showing the path. So this is the path or the beta. Okay. So you can change that to maybe F square. So you can see that it is now reporting on the F square. So these values have changed. You can change that to correlation.
Okay.
You can change that to indirect effects. Okay. But when you do that, you're supposed to let the readers know that these values are maybe the indirect effects. Okay, because ideally we always report on the path, the estimate or the coefficient. So now somebody sees that you have this to be 0.00. So it means that this is predicting that if the coefficient is 0.0, really, the person will not understand. Even this is having a negative attached to that. Okay, so you can also leave it blank. So let's look at the measurements. The measurement is the outer loadings. So you can change that to outer loadings. So that's the automatic one that we have here. And you have the weight. So this has now changed to weight. Okay. And then we have the weight and the loadings. Okay. So let's do that proper. So if you want to see the p-values, you are supposed to run the bootstrap. Now, what is the difference between bootstrap and then the PLS algorithm? If you want to see the statistics relating to the measurement model, so that is where you go to PLS SEM algorithm. Now, if you want to see the statistics that relates to the structural model, the inner model, or the structural model, that is where you go for the bootstrapping. So the bootstrapping will give us the results or the statistical outcomes of the structural model. Okay, so that is where you can find your p-values and the rest. So let me uncheck that. And you can bootstrap using subsamples. So automatically it is 5,000. It rerounds on 5,000. So although your sample size might not be up to this, but it automatically rerounds your data set for you using 5,000 subsamples. So that is what you term as bootstrapping. Okay. And then you can change this one to fast or slower. And then you can save the result per sample. And ideally, the test type is 2-tail. Okay. And then in social sciences, we use 0.05. as p-value. Okay, so you can change this one to faster or slower. So the faster model will give us the results very quickly. So let's see. So you can see that I've unchecked the report. So now with the structural model, I'll be able to change the values. Okay, so now all that I see here, the structural model is reporting on the p-value. So it means that from digital access to academic outcome, the p-value is what? 0.0. So it is highly significant, right? So that's what we see here. I can change that and report both on the coefficient and then the p-value. So I have 0.503 and it is significant. For this one too, I have 0.350 and it is what? Significant. This one too is also significant. So same applies to the outer model. I can report on the p-values. So all that I see here is that the indicator loadings are all having significant p-values, right? So you can change that and then include the weight or the loadings and then the p-value. So you can see that although I selected weight in here, the weight or the loadings, but it reports on the loadings because we are dealing with reflective model. We are going to come back to this proper, the reflective and then the formative. But what we are doing right now is what is termed as reflective. Okay, so with reflective, the arrows are pointing outwards from the latent variable, and then it moves outwards to the indicators, right? So you can see that the arrows are out. You can also change that. You can invert them. Okay, so let me invert that, and you can see it is automatically calculating because I've already activated my automatic calculation. So you can see that the arrows are pointing inwards. So this is what we term as formative. So if we invert again, you're going to have it pointing outwards. So all that we have been dealing with is termed as reflective model. All right. So you see this one, you cannot report this one as it is. You have to make sure that it is visible for your readers. So you have to reposition it. So that's that same thing we did here. You can see that the output is very clear. There's no overlapping. Okay. But when you do it by yourself, you realize that there are some overlaps. So you have to reposition it as an author. You are supposed to reposition it such that your readers will be able to see what values that you are dealing with. Nice. And the software will give you this green highlight to show that yes, it is in line. That is why you see that this is very well in line. So this software does this for you. It helps you. You can even move this around. Okay. But automatically, you can just do it by selecting and then use this one. It automatically move to the top or to the right, whatever you want to. Okay. So that is it. Within the inner model or the construct, you can also show, so automatically this is the R square. But if you want to do something different, you can show the AVE. So now you can see that the AVEs are showing in here. And you can report these separately. But once you do them on table, you don't need to do that. Okay, so that you don't do redundant work. You have already shown them in the tables and you want to show them in graphics. So you just have to stick to one. Okay, so now you can change them R square and then adjust the R square. And then whenever you do that, let the reviewers know or let the readers know that this is what you have done. Okay, so you can also do this.
Yeah, Prof.
Yes, boss.
Yeah, please. The reflective and the one reflective and you converge it. What is the? Can you explain that for me again?
Okay. In social science, I wanted us to come to this next week, but let me give you a brief overview of that because it's a whole. We have different types of reflective and formative, so it's a whole class on its own. But reflective means that most of the time the questions that you ask the participant, the indicators here are mostly correlated with each other. Okay. So the question that you ask the respondent. So let's see the paper that we talked about. Let's see if I've not deleted that. This one. So this was asking, let me see. Let's look at this one. Sustainable product design and development. So let's look at the first indicator. It says that our product design eliminate the use of hazardous material. So this is more about design, right? And let's look at the second question. Our product design facilitates repairs, rework, and refurbish. So you can see that this one and the first one, the second one, there is an association between. They are all talking about design, right? So there is some kind of association between that, and all of these questions in here put together is a reflection of sustainable product design and development. So that's what they call reflective measurement model. So the questions that we ask mostly in social sciences are just reflection of the construct, the underlying construct that we are dealing with. I don't know if that is clear. But with formative, no, basically with formative, the respective indicators are sometimes they don't have any correlation at all. Yesterday we looked at socioeconomic status. Okay. So let's look at where's my PPT? So socioeconomic status. We said that it is made up of income, education, and then where can I find that? This one, right? So let's see. So let's look at this one. Okay, good. So let's look at this one, socioeconomic status. Socioeconomic status. It is formed from income, education, and then occupation. And these are not something that are related. Your income is not associated with, I mean, the measurement of income and then education, they are not underlying indicators that are related. Okay, so income, education, and then occupation are measuring something distinctively. So these three things put together is what forms socioeconomic status. But you can see something like job satisfaction. Job satisfaction is an abstract concept that is very hard to measure, and then we can even operationalize it in many different ways. Okay, yesterday we looked at operationalization. So we ask questions that are related to each other that reflects job satisfaction. So this is reflective. You can see that these are pointing outside. So I am satisfied with my job. I enjoy my work. I feel valued and appreciated. I feel motivated at work. I'm happy. All of these things are reflections of what we can term as job satisfaction. I don't know if your question is answered about it. Different.
Yes.
Thank you very much. So in the software, so we come back to this next week if time permits us. And you can do that. You just right click and then you embed. So, okay. So when you right click, you can do a lot of things. You can even delete the entire model. So let me stop calculating and then delete. Okay, so you can see that it has all vanished. But you can undo that. And once you undo, you see that there are no values. So you have to recalculate. Okay. So let me activate my calculation. So you see, we didn't do any calculation here with the calculate, but we are at the interface of bootstrapping. So when you do recalculate, it automatically does that for you. All right. So that is it. Once you right click, you can change the measurement model to reflective or formative. So that is it. You can even hide the indicators. So now this is hidden. So you can see that it is not showing anymore. You can hide them. And then you can also edit. Okay. You can edit it. You can sort this using the import order or graphical order. You can see that this is in a particular order, A01, A02. So this one I think you can explore. You can also increase the margin. Okay, let me check the chatbot. Do you have questions in there for us? The picture or the code is not showing at my end. Please can you share? Okay, so the person should check the inbox. So that is good. So far, so good. That is the measurement and then the structural model. I don't know if there's any question for us. Is there any question so far? So these are the fundamentals of smart PLS, especially using the SEM. Okay. Any questions so far? Martin, please go ahead.
Yeah, okay. I saw that, I think at the bootstrapping, you were changing, let's say, R square, adjusted R square, and then the values were appearing on the path, right?
Exactly.
Graphically.
Yes.
So when you are writing like an article or you're writing a research paper, which one is best? Which one is better to use? Is it the tables, or you can just copy this graphic? Let's say R square adjusted. So do you just pick these graphics and then you paste it, whereby it means that you have multiple graphics
Exactly.
reporting different. Yes.
Yes.
So which one is best?
So
The
ideally, it is
tables
always
or
good to report them in table, because if you have to, you see this one, you can have all of these in graphs, but you cannot report each and every one. So it is better to merge them in one table. Okay. So you can see that here we have the reliability and validity for this one in one table, right? So you have alpha, rho, and then AV in one table. Let's look at this man's work. Let's see what he does. You can see for him, he has merged the measurement model all in one table, because he was dealing with two different analytical approaches. He was using the linear and then the nonlinear approach. And you see, linear approach will give you a lot of tables, and you are going to even add the nonlinear to it. So what he did was that he merged the measurement model. So you can see that this is the row A, the Chroma alpha row A, reliability, average variance extracted. He has put everything in one table. You can see that his variables are very much like they are too many. So this is what he does. And then he put together the Fonaraka also in the same table. So can you see that? And then the HMT also follows. So he has put everything together in what? One table. All right. But look at what we did. We separated the discriminant validity. So this is our discriminant validity here. And this is our reliability, and then the convergent validity. So it all depends on you and the journal. Because I remember this paper, when we finished writing it, we had to. So if you can check this one, let's look at this. This is only 10 pages, right? And from the introduction, you can see that we moved straight to the conceptual framework and then the methodology. So there is no literature in here. So when we finished, and then they came back and saying that we have to limit our references to only 40. So we have to restructure the paper. So what we did was that we sent other areas of the paper. So the literature review was sent to it was sent as part of supplementary material. So if you want to see the literature, you can find it here. So when you tap on this, it will give you access to download the literature that we did. So some of these changes can be affected, especially when the journal asks you to do that. Every journal has their own limitation. Most of the journals in Emerald, they have a limited number of tables you can report on. So looking at this study, if you have to report on each of these in a table or figure, it means that you're supposed to do, for this one alone, you're going to have three tables. And even when he merged them together, he even had to come back and report someone in what appendix. I don't know if you can see that. So there are a lot more of tables reported, even in figures. So the presentation is all dependent on you and then the journal. But ideally, just get one or two papers, three papers that have been published within your area, and then you check, compare, and see how best you can put them together. It all depends on you. I don't know if your question
okay.
is answered.
So yeah, which means what you did It's just for your preview, just to see a few things graphically, and then now you can, when you are
Yes.
satisfied, you
So
can just copy the table.
so if you look at this one, we reported all of these. We reported the R square in the table, right? In the structural model. So the R square can be found somewhere here. See. So the R square is here. Okay. The R square is here. Then just the R square, the Q square, and then the other measurement aspect. We're going to deal with this next week. But together, we have put them in an image. So what we said was that the structural model is depicted in figure 2 with the corresponding coefficient and coefficient of the determination for the endogenous construct. Okay, so this the R square is the same as coefficient of what? Determination. So we made it clear that we have put together all the figures for the purpose of robustness and then in accuracy, and then we're also having confidence in the fact that you have used the software. You can also point all of these out so that it's graphically somebody who wants a specific thing can just click into the tag. Okay, so this is the beta, this is the part, and this is so ideally what we show here is the R square, and these are the loadings, and these are the p-values of the loadings. Okay, so I think we have already demonstrated that. This alone will let the reviewer know that okay, this was above 0.7, so all of the criteria are met. This and this and that. Okay, this was above that. This was above that. Then you are good.
All right, thank you.
Thank you very much. Any other question? So it means that we are good. So today we have learned how to go deeper into the measurement models. Let's see how we can export them. If you want to copy this image, you can just right click and export. Okay, you can save it in PNG or CVJ format. You can also hide comments if you have comment in it. You can override the background. You can change your background settings to a specific color. Okay, and then you can copy. So if you select clipboard, it means that you can copy it on your machine. Or you can copy it on your clipboard on your machine, and then you can now select wherever you want to. So if you want to copy it to clipboard, you can export it, and then it will be saved on your clipboard. And then maybe you want to save it somewhere here. You just Control+V, it will just come here. So this is it. Okay. And if you want to export it externally, here you have to just choose a specific directory where you want to save it. So assuming that I want to save it in my NUGS-PLS tutorials, you can just save it in here. So once you go there, you find the image. You find the image over there. So this is it. You can see that here. So this is the workspace. So whatever that we have done, you can see we have the SPLS SEM. The result as shown here. What you have done. This is in the test form. This is other extensions that we can have. So this is what the workspace does. Whatever you run, it saves it for you. That's why when you come back to it, you're able to get back your output in the same fashion as you left it. It's already saved. It is linked to this. Okay, so any conversion that we see, okay, it is linked here. Okay, so that's the importance of the workspace. So is there any other question? So far we are good. You can always also export the results. So you can export it in a plain format. You can add the graphs to it. You can also add the model image. You can also exclude matrices. So you can also export that in Excel. So let's say I want to save this to my Excel. So let me call this one Bootstrap. So because this is the results for the Bootstrap. So let's say Bootstrap. So it is now saving it for us. So now this is it. So everything that we have done, you can have them here. So let me close this one a bit. So you can see that the relationship between this and that, the original sample estimate. Okay, so what we said it was beta, it is shown as original sample. Oh, and then the original sample mean. Okay, so this is the coefficient, and this is the standard deviation. This is the t-statistics, and these are the p-values. Okay, it also shows the confidence interval, and then the bias corrected confidence interval. But you can see that these are missing. Okay, the values for the intercept, total indirect effects. Okay, we didn't do indirect effects because we are not typed on mediation yet mediation moderation. But with the bootstrap, not everything will show. For example, let's see average variance extracted. You see it didn't come. The absence of this result is intentional and aligns with your model or choosing algorithm settings. When you start bootstrap, for example, when you start bootstrap, choose the complete slower. Okay, so if you want to also have access to the statistical report on the conditional direct effects, indirect effects, quality, R square, although the R square can be found on the PLS algorithm, but if you want to find them also in the bootstrap, then you have to reactivate your listing from complete faster to complete slower. And I think we did that here. So when you are running the bootstrap, you just have to select complete slower. So when you do that, it will take a lot of time to run, and it will run to give you full access to the other aspects that we're missing. Faster one. So it has to run one by one the saturated model. Okay, good. So now I have them here. So I can also open them here. Okay, in the quality criteria. So you can see that I have my S-square, and the S-square also reports on the statistical significance. So is my S-square significant? Yes. So AVE2 is also giving us p-values. But you know, AVE, our focus is not on the p-value. Our focus is on the score for the AVE. So these are not really important. That's why you can always omit them. We will see also giving us the same thing. So all of these things are in the results already. So there's no need for you to. So this is the latent variable correlation. We're not going to report on that. Inner model. So I wanted to show you this to show that, yes, if you use the slower, it gives you full reports. But because we use the faster, that's why these values are missing. Okay. So when we export this one, you're going to have everything in full. Okay. So you can always export your results, or you can just simply copy the outcomes. That is all. Any way that fits you. You can just copy that and then paste it in Excel or even Word. It will go through. That is it. So that would be all for today. And then next week when we come, we're going to deal with mediation and moderation. Then we are going to touch more on what happens when your loadings are not above the required. Okay, so some of these things we have criteria for assessment. It can happen that your loadings are lesser than the threshold of 0.7, and sometimes you can have 0.6, you can have 0.5, you can even have negative values. So sometimes happens, and in most cases, when you have negative values, it means that you negatively worded some of your statements. Okay, and yesterday we touched on that. We said that it is always good to do that so that it is an ex-ante principle to use in your questionnaire to see whether your respondent actually answered the question by reading and understanding it, or were they just taking the patterns. They think that, oh, okay, everything is positive, so they believe that, oh, okay, if I agree, then I'll go for 4, 5, 4, 5, 4, 5, or maybe 3. But if they agree, if they really read the statement, it means that you would have to note that, yes, okay, at the point, some questions were negatively worded. So I'm happy. You can just change it to I'm not happy. So somebody who is happy would have to go for the negative, the strongly disagree, to show that, yes, I am happy. Because so if you say that I'm not happy and you go for strongly disagree, it means that, yes, you are happy. So that is it. Any questions so far? So today's assignment, let's go and explore on the PLS SEM algorithm, the bootstrap, and how to navigate our ways on having this here, the showing different values on the outer loadings and then the inner loadings. Okay, so this is today's assignments, and next week let's present on that and then we go ahead. Okay, so thank you very much for joining, and we're going to meet next week. God willing.